Today we're going to discuss section 3, congruent triangles. This section is really setting up our return to two-column proofs. So what we're going to discuss today is what does it mean for triangles to be congruent. So the first sentence says geometric figures are congruent if they are the, and we're going to fill in same size and same shape. Same size and same shape. Oops, let me fix that. Same size and same shape. So both criteria must be met in order to be congruent. Second one says we're going to add corresponding angles in the first blank. Corresponding angles. Corresponding, and I'm just going to use the angles symbol. Corresponding angles and corresponding sides. And I'm going to abbreviate since it's a little hard to write in that blank. So this sentence says corresponding angles and corresponding sides are in the same position in polygons with equal number of sides. Lastly, two polygons are congruent. So we want the word congruent here. Two polygons are congruent if and only if their corresponding sides, so I'm going to circle that, corresponding sides and angles are congruent. So both sets of corresponding sides and angles must be congruent. Now corresponding is something slightly different than what we discussed with parallel lines. But it still has the same meaning in that it's in the same general location but maybe a different triangle. So let's look at this, this property box right here. So it says here we've got two different items. We have a set of congruent triangles and a set of congruent polygons. So corresponding angles would mean since angle A has a single arc and angle D has a single arc, they are congruent. So they would be considered corresponding. Angle B has double arcs and angle E has double, so they're congruent. And then angle C has triple arcs, so does angle F, so those are congruent. Now the corresponding sides would be the sides that are congruent. So AB has a single tick mark, so does DE. So it says over here AB is congruent to DE. The double tick marks BC and EF. So notice BC congruent to EF. And then the three tick marks AC, DF. So AC and DF. Now this right here is called a congruence statement. And notice the order it's in. The A is the first letter and the D is the first letter, and they are congruent. So we must write that statement in that order. So B is the middle letter. It must go with E because B and E are the congruent angles. And the same with C and F. So I want you to maybe circle this. And I'm going to scoot my page over here. So this is called a congruent statement. Congruence statement. So when you're asked to write a congruent statement, that's what you're going to be writing. Okay, so let's go ahead and look at this example here at the bottom. It says that we are given PQR is congruent to STW. We're going to identify all the corresponding congruent parts. So I'm going to start by drawing this one. So let's draw a triangle and let's call it PQR. So PQR. And then draw the second triangle and that's called STW. And so let's label the things that are congruent based on the way the statement's written. So P is the first letter, S is the first letter. That means they are congruent. So I'm going to put an arc on P and then an arc on S. Q is congruent to T, the second letter. So I'm going to do a double arc on Q and a double arc on T. And then R congruent to W, so I need triple. So 1, 2, 3, 1, 2, 3. And then I can do the same thing with sides. So because PQ are the first two letters, that means that segment PQ is congruent to segment ST because those are the first two letters. So PQ will get a single tick mark, and so will ST. The second and third letter, QR, and then TW. So QR would get double, TW would get double. And then finally, we have the first letter and the last letter. That's a segment. Segment PR is congruent to SW. So PR would get 3, and then SW would get 3. So that's labeling everything. So let's write out all of those statements. So I've got here that angle P is congruent to angle S. So I can go by the name or I can go by my picture now. I know angle Q is congruent to angle T. And then I know angle R is congruent to angle W. So those are my 3 angle statements. And then I have 3 segment statements. I have segment PQ is congruent to segment ST. I know that segment QR is congruent to TW. And then I also know that segment PR is congruent to segment SW. So I have listed all my pairs of corresponding congruent parts. So I have 3 angles and 3 sides. Okay, let's go on to the next page. So I'd like you to try that on the next example. So I'd like you to go ahead and pause it. If you want to draw a picture, you can. If not, you can just write out actually you have polygons this time. You have a 4-sided shape. So you'll have 4 sets of angles, 4 sets of sides. So let's pause it and do that on your own. Okay, I'm going to do a sketch here. And if you did a sketch, you can follow along. Actually, I'm going to make that a little bit bigger. So I'm going to I'll just make it into a rectangle. I've got L, M, and P. And then I have a second one. I've got E, F, G, H. Now I'm going to try to label everything on here, and it's going to get a little bit messy. So I'm going to label angle L and angle E are going to be congruent. Angle L and angle E. And then I'm going to label M and F. So I'm going to go in order. Since I'm given the statement in the directions, I can go in that order. M and F. So I'm going to do 2, and I'll do 2. N and G. So N I will do 3, and G will get 3. And then finally P and H. So 1, 2, 3, 4. 1, 2, 3, 4. And then same on sides. Segment LM will get a single, and segment EF will get a single. MN gets a double, and then FG will get a double. NP gets 3, 1, 2, 3, and then GH will get 3, 1, 2, 3. And then finally L and P, so that would be 4, and then EH would be 4. So let's write that out. I've got the angles. I have angle L is congruent to angle E. I have angle M congruent to angle F. I have angle N is congruent to G. And then I have angle P congruent to angle H. And then my sides. I have segment LM congruent to segment EF. MN is congruent to FG. NP congruent to GH. And then finally LP is congruent to EH. Okay, so again, this is listing all the pairs of corresponding congruent parts. So we can use this idea to actually solve problems. So we're going to do that on the next couple examples. So I am given here that these triangles are congruent. So what that tells you is that all 3 sets of angles are congruent and all 3 sets of sides are congruent. So I want to find the value of x. So when I look at this, the value of x is located within this expression. And so there's a couple ways I could do this. I see that the value of x right here, this angle C, or actually the 2x plus 18 is pointing at angle C in triangle ABC. So angle C is the third letter, or third angle. It is going to be congruent to angle C in the other triangle because they're in the same spot. Well, angle C in the other triangle is 90. So I'm going to be able to write that equation based on the fact that these triangles are congruent. So 2x minus 16 equals 90. So we would add 16. So 2x is equal to 106. And then you're going to divide off your 2, and that will give us 53. So that's the value of x on that one. The next one down, same triangle. I want a different angle. I want angle DBC. So angle DBC is right here. So I need to see, well, what angle is that congruent to? So angle B is the second letter, and it's congruent to the other angle B. So in the other triangle, it will be congruent to this angle right here, but I don't have that measure either. But I can figure it out. So I know that this angle here is 90. Because if I have a set of perpendicular lines, both sides are 90. So now I can figure out what the blue dot is equal to. So I can do it one of two ways. I could do the triangle sum theorem where they all add up to 180, or I could just simply do 90 minus 40, not 43, 90 minus 49.3. And when I do that math, I get 40.7. So the measure of angle DBC is equal to 40.7 degrees. Okay, I'd like you to pause it, and I want you to look at the two U tries at the bottom. Okay, in the first one, I want to find the value of x. Well, x is located along segment AB. And so I know based on the congruent statement that AB is congruent to DE. So if I want, I could put a congruent mark here. Maybe not over 53, but I can put a congruent mark here. And then DE is right here as well. So those are the two that I can set equal. So 2x minus 2 equals 6. Add 2 to both sides, you get 8, and divide off, it's 4. So the value of x is 4. On the second one, I need the measure of f. So angle F here is congruent to angle C. So I know F and angle C are congruent. So I can figure out angle C in this triangle by doing triangle sum theorem. So once I know C, then I know they're congruent. So I can do 90 minus 53 here. And I end up with 37. So the measure of angle F equals 37 degrees. Okay, moving right on to one proof to finish up here. So what I want to do is do the second one with you. So we're building our way up to a full proof, but we're going to do several in our notes together. So let's go ahead and make our columns. Statements and reasons are going to be the titles. So go ahead and label statements, reasons. And I want to start out with my givens. So I have 3 givens. So I'm going to say that in line 1, I'll go ahead and write all the givens. So segment AD bisects BE. I know that segment BE bisects, it says AD, and then write the third one down. The third one is going to be, actually there's 4 givens. I've got AB, segment AB congruent to segment DE, and angle A is congruent to angle D. All of that is given. Okay, so before I go any further, I will mark what I can mark. I'm only going to mark things that are shown congruent in the proof. So I'm going to mark this AB congruent to DE. Actually, it's already marked for me. So AB is right here, and it's congruent to DE. And the angles are marked for me. Notice I have a red arc on A and on D. If it wasn't there, I would label it. Okay, my next step then, I'm trying to show the two triangles are congruent. So my next step, I'm going to use the bisecting thing, the bisecting givens. So let's think about what bisect means. It means chop it in half. So AD is this segment. It says it is bisecting BE. So AD is doing the chopping. So AD is cutting BE in half. So I know that BC is congruent to CE. And the reason is because definition of bisector. So let's write that statement down. Segment BC is congruent to segment CE. And we'll call that definition of bisector. You can call it definition of segment bisector, but I'll just shorten it to bisector. So for that matter, if I look at the next one, BE is bisecting AD. So BE is coming through here and chopping AD in half. So I also have that these segments are congruent. So put 3 tick marks on them because they're different. So I'll just add that underline too because it's going to be the same reason. AC is congruent to DC. Okay, so in order for triangles to be congruent, what I need to show right now is all 3 sets of sides are congruent and all 3 sets of angles. I have accomplished my 3 sets of sides. I only have one angle, I need the other 2. So I need to look for some other angles. And so one angle that I see, I'm going to put double arcs on C on either triangle. And you should look at that and recognize those are vertical angles. So I'm going to write number 3 down. I can't just write C congruent to C because there's 2 different angle C's. So I need to use 3 letters. So I might call the one on the left angle ACB. So angle ACB is going to be congruent. We could call the other one DCE. And our reason is going to be vertical angles theorem. Vertical angles, and then theorem you can shorten to THM. Now I need one more set of angles to be congruent, and we talked about a couple days ago that if you know 2 angles in one triangle are congruent to 2 in another, well, the third pair must also be congruent. So I'm going to try to get 3 arcs here. And that's called the third angles theorem. So since angle B is the only angle that is attached to a triangle, it's not attached to both, I can actually call that angle B. So I can say angle B is congruent to angle E, and the reason is third angles theorem. Third angles theorem. Now I'm done. I've got everything proven to be congruent. So I'm ready to rewrite what I'm proving in the last spot. So I'm going to recopy that down. Triangle ABC is congruent to triangle DEC. And really what we just did is we used definition of congruent triangles. So definition of congruent, and I'm going to use the triangle apostrophe S. Okay, so that is a full proof using this definition. So check Canvas for the assignment, and we will talk more about this next class.